Hello, everyone. We are here with the fourth Guru Online. I'm going to talk a little bit about myself. My name is Vitor Talaia. I'm organizer of GURU Sorocaba. And GURU Sorocaba is an organization that we created here in Sorocaba to talk about Ruby and other technology. We're polyglots, so we talk about a lot of stuff, not only Ruby, but our main focus is Ruby. And today we're doing another Guru Online, which is a meetup that we are doing once a month online to promote speakers of the region and to make their talking English, to promote that culture of talking English to the community, show the world what our community worth it. And today we are here with Vitor Talaia, which is a developer from Sorocaba. He's very good at what he does. And he's going to talk about Crystal for us. And I want just say something about Talaia, that he's going to talk on Perf Matters, which is a conference in California, right? In Redwood. And a conference about web performance and client-side performance, focus on web front-end and web performance. So yeah, that's it. And I'm going to pass the word to Vitor. And again, thank Vitor for the talk.
Okay, thank you, Kate, for the introduction. And thank you guys for having me here today. So yeah, that's it. I think I'll start sharing my screen right now, so you can see the slides. Just a second. Okay, I'm sharing my screen. Just see. Go for the screen. Okay, are you guys seeing my slides? Is it okay? Okay, so tonight I'm going to talk to you about Crystal and how to write CLI applications with it. My name, as Kate already said, is Vitor Talaia. I'm a developer at Code Miner 42 here at Sorocaba. And this is my handle on most of the social networks. So if you guys would like to reach me out, this is the handle. So let's start. Why Crystal? Why Crystal is a language that you should pay attention to it. Well, first of all, I'm going to talk about the goals that the creators of the language had. So the goal was to create a language that is fast as C and is sleek and expressive as Ruby. So this is the main goal of the Crystal language. Is supposed to be a really fast language, but keeping the benefits of a high-level language like Ruby and Python and so on. So an important thing to say is that Crystal is not Ruby. It's different from Ruby. Despite having a lot of inspiration on Ruby, you can see it by the syntax I'm going to show you. Compatibility is not a goal, so not every Ruby code can be compiled into Crystal, despite it is possible with simple snippets and so on. This is a PR that this dude opened to add the zero method to the number class. So it was rejected. It was not remerged because the creators of the language don't want to copy every Ruby aspect, every single thing that exists on Ruby. They want a simple language, a simple and fast language that can be both expressive and fast. Okay, another thing about Crystal is it is compiled. So it's compiled using LLVM. So it has the same benefits as other languages on the platform, just like Rust and Swift. And most, actually not most, but part of the speed of the language, the optimizations are done by LLVM. So it helps Crystal to be even more efficient in terms of speed. And LLVM has this beautiful Iron Dragon as its logo. It's really cool. Another thing I want to talk to you guys about Crystal is that the language is self-hosted. What does it mean? It means that all parts of the language, the entire compiler, the entire lexers, the standard library, everything is written in Crystal. So, like the creator of Ruby, Matt, he describes himself like most likely a C programmer than a Ruby programmer, because when he's writing the source code of Ruby, he's actually writing C, not Ruby. And this is not the same thing. This is not valid for Crystal, because the Crystal itself, the language itself, is written in Crystal. So it can be really cool for one that is trying to learn Crystal or want to know more about how the things work under the hood, to get to know more about the language. So it is easier for them to understand the code. And this is cool. Okay. Another difference between Crystal and Ruby is that Crystal is static type. What does it mean? It means that Crystal have types notations like Java. You need to declare the types for every variable, every method, and so on. But a cool thing that Crystal has is that you are not obligated to do that by hand. The compiler is really good at trying to find the type of a variable or a method in runtime. So not always is need to write a type notation. Like this example. This is a simple method called hello that receives a string called name and returns a string. So this is the notation for this variable called name, and this is the notation for the return variable that is also a string. But the cool thing is that we don't need to do that. We can simply omit the type notation, and the compiler will know that what type is it. It has a good typing inference engine, so it's really cool. If you ever written some Ruby code, this is exactly like this. This is valid Ruby. This is valid Crystal. There's a thing that I love about the language, is this thing called union types. What are union types? Union types are, as the name says, the union of two different types. So here we have this method called print something when you're receiving a variable called something. And this variable can be, at compile time, both a string or an integer. So it is really cool, because we can say that this method receives both, this variable can receive at the same time a string or a number, and it will not fail. It is really cool. And if the class that are passing here, the type has the method, it will work. I'll show you later an example of this. So this is an explanation about the union type. So here we have a double method that just receives a variable called something. And if something is bigger than 5, it will double the value of something and return it. If it is not greater than 5, it will just return the string failed. So here at runtime, this dot class here is the runtime type. We always define a type, like if we pass 4, it is not greater than 5, so it will return failed. And the class of failed is a string. If you pass 6, 6 is greater than 5, so we'll get a number, and the class of the number will be integer too. But the cool thing is that at runtime, at compile time, it will be the union of these two of these two types. So at the same time, this variable, this method can return both an integer and a string, and this is really cool. And being compiled delivers some powers to Crystal, like this one. Here we just have a method called getName, and it will generate a random pseudo random number. And if it is greater than 5, it will print Vitor, else it will print name. So both options here, both returns are strings, and both strings have this star method. So we'll get like Vitor and name because we will repeat the string. But what will happen if you have something like this? When we have two options here, we return a string when the random number is bigger than 5, or we just return nothing, nil, when it is not greater than 5. So here you have a compile time error, because Crystal will try to check if the type of the variable, in this case a string, has this star method, and it has, so there is no problem. But when the compiler will try to see if the new class has this star method, it doesn't exist. So it will throw an error in your face and it will not let you compile your code. And this is cool because in languages like Ruby and JavaScript, a lot of interpreted languages, we have a lot of errors like, oh, undefined method X for new, or X is not a function, and so on. And this is cool because we can catch those errors in compile time. Another cool thing that union types allow the language to do is something called the overload, method overloading. So instead of writing methods in this labeled signature like this one, where you can receive a string and an integer, we can create two methods, but they are not the same, because the first one we receive a string and the first one we receive an integer. So we can create two methods that have the same name, but will do different things depending on the type of the variable that they receive. So here we are calling the method with the string A. Oh, sorry. And by calling it with the string A, we are calling this method here. So it will print call with a string. If you call it with 777, it will just call this method and your print call with a number. So this is cool because we don't need to do that ifs to type checking the variables and so on. So your code will be a lot more cleaner than if you have to write the if statements or do any kind of type checking. And this also works for number of arguments. So like in this case, both methods receive the first parameter, an integer, but the second one receives a second argument that is a Boolean. So if you call just with an integer, it will call the first one. If you call it with an integer and a Boolean, it will call this one. So it is not just the type of the variable. The number of arguments is also taken into account when creating this. And another nice thing about the language is that despite it being a relatively new language, it has a great standard library. So we have things like, we have cool things that language that have the same speed, the same performance, usually don't have, like HTTP client, HTTP servers, markdown parsers, OAuth, WebSockets, and so on. And the community is also growing around Crystal. So we have like a sidekick implementation for Crystal. And as a highlight here, this guy, Mike Perrin, he's the creator of Sidekick. He's saying that, let me know, oh, here, on this line. He's saying that he started this project from scratch, not knowing the language, and a week, and in 3 days he got a core processor running. So just in 3 days, a Ruby programmer was able to create a library for Crystal in a complex library like Sidekick in like no time. It was really straightforward for him. Another thing that is cool for the language is this thing. This is called the linking. So we can link C libraries and use its functionality in Crystal. So let's pretend that we have a C library called hello. And here we are creating a link between this C library and the Crystal program. Oh, sorry. And the Crystal program. So we create like here a lib hello that calls this function, this library. And we can use it anywhere in your code. So anywhere where you call lib hello.hello, you execute the C library instead of the Crystal code. So if you don't find any library that will help you with something, I'm sure that that there is a C library for that, and you can leverage on Crystal to link it for you, and you're then be able to use it in your code. Okay, this was the first part of the talk. Let me just grab some water here. And I talked mostly about Crystal and its characteristics and its differences from Ruby. And now I'm going to start talking more about writing CLIs applications with Crystal. And CLIs are a good case for Crystal, by the same thing that they are using Go to write CLIs application concurrency. Crystal is also really good for that because we can generate a very good binary by using LLVM, and we can kind of make sure that it runs faster anywhere. It will be multi-platform, and it will be like optimized by the compiler and the platform, the LLVM. Okay, the first thing I want to talk to you is the option parser. It is present on the standard library of Crystal. So it is really close to the option parser that comes with Ruby. And it exists to help the programmer to receive parameters or values through a comment. So this is a code that uses this option parser. The first thing we need to do is to require the option parser. We don't need the / thing here because we are requiring a thing that is built in the language. After that, we are declaring two variables, variable name that receives an empty string, and variable string that receives a false value. And after that, we are creating our options. So we have the option parse method, and it receives a block that can be executed there. The first thing that we do is to create a banner that will be displayed when we type the help option. And here we are creating an actual option. So we're saying that when someone enters -n or --n and pass a value, we are going to store the value and the variable name. The same thing here happens to screen, but the difference here is that we are not receiving a value from here. Here we are receiving this value. The name constant here means that we receive this value on this variable and we will reassign it to name. But on this case, we're just checking the existence of screen option here. So if there is a -s or --screen, it will just set the screen variable to true. And this third parameter here that you're saying, they are going to be used when we are printing the help text. So the help text is basically just printing all the options. So we're putting on the end of this parser, and we are saying, okay, if you receive /h or // help, you are just going to print all the options, including the help itself, and it will exit the code. Okay, this is the parser itself. After it is being executed, we continue to our program here. So we create a variable called message, where we just bring the name of the person, and if it is screen, we just use an uppercase version of it, like on caps lock. And if it's not screaming, it just prints hello name in a politely form. So this is how it looks. So if we compile this file, it will generate a binary for you, and you can execute it like this. I call it option parser, and when I passed --help, I just printed out some handy information here that can help the users on know how to pass information on how to use this application. If I pass a name like Word, it will just print the name of that was received. In this case, it is Word. If I pass name, Word, and the flag screen, it will just print it in caps lock. Okay, that's cool, but it is really simple. We can create subcommands with this. We are just receiving flags and values from the command line. If you want to create something more complex, like a real CLI application like Git or NPM or whatever, you need to use something more specific, or doing just like the compiler, the Crystal compiler does, create a switch case statement that will receive the subcommand. But in this case, we are going to use another library. So I'll explain that for you. I'm using on this example an API called Ergast, a Motorsport database that is MRD. And it is just an API that has a lot of information about Formula One. That's what I'm going to use as an example. The other thing is the Admiral. Admiral is a chart, like it is what is called a library in the Crystal environment, the Crystal ecosystem. Just like gem in Ruby, just like a package on JavaScript, there are charts for Crystal. And it provides you a very robust DSL in order to be able to create complex CLI applications in Crystal. So, okay, let's dive into the code. This is our entry point. This is basically, this is not the file that will be used in order to compile the code, but it's basically this. We are just requiring Admiral and requiring some folders here. I'm going to show you later. And we are basically creating a module called Ergast. And inside of it, we are creating a class called CLI that extends Admiral command. If you have ever written some Ruby code, this exactly like Ruby does extension of classes. So here we are using a method called define version that's just printing this variable here, this context. And another thing that we are doing is to create a help that we receive a string, and we are also registering some subcomments that will be used. So here we have two subcomments. We have seasons comment and we have staging comments. So the idea here is to write ergast CLI dash seasons like this, and it will print out all the seasons like from the series that you want to. And this is the class that will be used for that. So we are importing this, requiring this for this file. Okay, let's take a look. This is the help file for this application. So we have a UGS here that just helps the user to know what to do with the program. We have the flags that are just like the option parse arguments that we were receiving later. And we have these two subcomments. So here we have a nice help message for the users. And we can just know how to use that by seeing this. Okay, cool. Let's take a look at our first subcommand, the seasons comment. It will also extend the Admiral command class. And by doing that, we also have these two methods here, these two macros here, like define help, that we just print help message, and define flag, that you receive an argument, just like the option parse did before. Here I'm creating a run method that will just trigger a service that will get the season list. And after that, I'm passing it to a presenter class here. So I'm gonna show you first this service that just basically just triggers an HTTP request to the server. And after that, I'll show you this presenter that just creates a table in ASCII. Okay, let's take a look at the service. We are initializing here the class. This is a cool thing about Crystal. When you have an initialize method that just assign a value to a variable, you can just add this at sign here, and it will do like at series equal series. So we don't need to do that by hand. On the process method, we are just calling this method here, seasons requests, that will call this the API, the Ergast Motorsport database, and get the results, the JSON, to the parse response method. That is this one. Here you are basically creating these objects based on the data that we got from the server. These things here are the keys that I need to search for in the response body. So after that, I would basically just create an array of seasons. So this mappings here is just a module that contains a class called season. And this is the class called season. It's another cool thing about Crystal. Like I said, it has a great standard lib. So we have a JSON helper here. And we are just created here a mapping to a JSON object to an instance variable. So if you take a look here, we are calling season.fromJSON, and here we are just passing in the JSON object. And this from JSON method is delivered by this JSON mapping macro that will create this instance variable for you. So you don't need to receive an object and parse it manually inside your classes. And finally, this is the presenter. As I said, the presenter is really simple. I'm just requiring this chart here that I use it to create a simple table. And I'm just receiving an array of seasons. And here I'm iterating through this array and adding lines to the table as many lines as I got seasons here. So after that, we just call table.render, and we will have a nice and beautiful ASCII table. So let's take a look at examples here. This is the result if you compile this code and call the season subcomments with flag with dash series F1. It will hit the API and get all the F1, all the Formula One seasons that they have. So we have like 95 to 2017. The same thing will happen here if you use Formula E instead of that, because Ergas supports the Series 2. Another example here is the stagings command. We are receiving two options here, the series and the season. So if I want to know the stagings for the season of, I don't know, 2015, I can just say the CLI staging series Formula 1 season 2015. And here I got this nice and beautiful table with the results and all the things that I had to on this data. And it works basically in the same way that the seasons command that I showed you. We just have one more flag here. So this is the season command. We have just a series flag. On the stages subcommand, we have two flags. So we have two defined flags here, but the rest of the code is basically the same. We're just hitting another URL and of course calling a different mapping class and so on. But the code is basically the same. And if you guys want to take a look, it is on GitHub. And oh shit, it is broken here, but you can see it. Well, that's it. That's what I want to talk about Crystal and how to write CLI applications with it. And thank you everyone for this opportunity. And that's it.
Hey, can you mute it?
Oh, sorry.
Yeah, so first of all, I want to thank Talaia for his amazing talk and questions. See if the chat has questions. Yes. Hey, so Vitor, Ricardo's asks, does Crystal have something like a gem file?
No, I'm muted. The answer is yes. Crystal has a file called, I don't remember the name of the file right now, but it's a YAML file that acts just like a gem file. So you can write the libraries that you're going to use, and when you enter the project, you can just Crystal deps, and it will install the dependencies of the project. So yes, it has something like a gem file.
So another question from Lucas Renan. one of our founders, and he's asked, have you considered Go as an alternative for the CLI? Go.
Yes, definitely. I think the language are really equal in its goals. Both languages want to be fast and concurrent, and they are both great for this use case of CLI applications. I think the main difference between the two, Go is more, how can I say that? It's not more advanced yet, but Go is older, so it has a lot more of features. But I think Crystal will reach Go, and it'll be really nice to see these two languages competing in the market. But I think the main benefit from Crystal is that if you are a Ruby developer, you won't need to switch a lot of context. Like the Go syntax is kind of ugly sometimes. It can be really difficult for a newcomer. But for Crystal, it will be just like Ruby. It is not Ruby, but it is pretty similar. So I think it will be easier for a Ruby developer to write some applications with Crystal and get the performance and the optimizations that LLVM can handle.
So another question, Felipe, I'm going to leave your question to the end, but Eric Machado sent a question. When I have a compiled binary from Crystal, do I need any kind of dependency on my system, or does it work like Go binaries?
Yes, it will work like Go binaries. It will work anywhere. I just don't know on Windows what we have to do, but it will for sure work on any Unix-like system. So I'm pretty sure it's the same thing with Crystal or with Go. Sorry, I'm just not sure about Windows, but I think it will just work.
So I don't know if we have any questions. Please, guys, send more questions. I'll ask the question from Felipe. His question is: can you tell us more about your talk in California?
Okay, cool. I can talk about that. Okay, I submitted a proposal to the Perfumeras conference, and it was, I think, on later October or in the beginning of November, and I was just wondering if I could be accepted and if the guys will like to have me there to speak to them. And it was a really cool, I was really surprised when I got the email from Estelle saying that I was accepted to the conference. And it'll be great because there will be people from companies like Google and Netflix and Akamai and Amazon and other companies like that really care about performance. So I think it will be a great experience. I'm a little nervous about that. I'm a little anxious about that for sure. It'll be a great challenge. And yeah, that's it. It'll happen on March, I think March 28 and 29, if I'm not wrong. And it will happen on Redwood City. It's a city nearby Palo Alto and Mountain View. So, yeah, that's it. I'll talk about AMP. That's it started as a Google project, but now it is a commuter-driven project, and I'll talk to the guys about AMP and what I think is good and bad about it. And that's it. I really like the question.
So I think that's it. We conclude our fourth meetup here. So I want to thank Vitor for his amazing talk again. And thank everyone who's watching. And like our tradition, we're going to announce the next meetup, which will happen next month. We didn't set a date yet, but certainly will be next month, so January. And we'll be with Felipe Inocêncio, and he's going to talk about Gatsby. I don't know how to talk. Gatsby, which is a static site generator with React. So for all the front-end guys, it would be amazing. So stay tuned. We're going to create a meetup later. And that's it. Thank you, everyone. Thank you, Vitor. See you later.
Okay, thank you, guys. See ya.